In order to determine empirical formula, what you just saw was a fairly simplified version of finding empirical formula. All the information is given to you, you get into moles, divide by your smallest number of moles, and then you can determine your empirical formula. Well, what if it's not so obvious? Okay, so let's look at a problem here. If you notice, it tells you that the compound only has carbon, hydrogen, and oxygen. Okay? You've got a sample that burns an oxygen and it produces that amount of carbon dioxide and that amount of water. So it says calculate the individual masses in that sample. Well, it's going to be pretty easy to figure out carbon and hydrogen. Just like what I did previously in going from grams of a compound into grams of that element, I can go from grams of carbon dioxide into moles of carbon dioxide into moles of carbon and then get into grams of carbon. Okay? And so that's exactly what you do here. So you start off with a mass 1.9061 grams of carbon dioxide, get into moles of carbon dioxide, get into moles of carbon, and then get into grams of carbon by multiplying by its molar mass, and that is the mass of carbon that you get. Okay? You can do the same thing for hydrogen. Now the only different thing here for hydrogen is that for every 1 mole of water, there are 2 moles of hydrogen. Okay? So I'm going to go from grams of water into moles of water. Then the ratio, the mole-to-mole ratio, is 2 to 1. You've got 2 moles of hydrogen for every 1 mole of water. And then you can get into grams of hydrogen, and there you go. You've now got grams of hydrogen. If you notice, oxygen is in carbon dioxide and water. So what I can do, instead of trying to get into grams of oxygen from both of those, what I can do is say, all right, I know that I start off with a sample that consists of carbon, hydrogen, and oxygen. I know that I have 0.5202 grams of carbon and 0.03771 grams of hydrogen. The rest of that must be oxygen. So I'm going to take the total mass of the compound, which is 0.7579. I'm going to subtract the mass of carbon from it and the mass of hydrogen from it. And there I've got my mass of oxygen. So now we just solve for A. We figured out the mass of carbon, hydrogen, and oxygen. Now this is just a typical problem where I've given you the mass of your 3 different elements. Now we need to convert into moles of each of those elements, divide by your smallest number of moles, and then figure out the empirical formula. So let's do that. For moles of carbon, that was the mass of carbon I solved for on the previous page. I'm going to divide by the molar mass. There are my moles of carbon. I'm going to do the same thing for hydrogen. Okay, there are my moles of hydrogen. And there are my moles of oxygen. Remember, what you have to do now is decide which of those is the smallest value, and that would be the moles of oxygen, the 0.01231. So I'm going to take all of those values for moles and divide it by the 0.01231. And that's exactly what I did there. Okay? And so what I get is 3.5 moles of carbon, 3 moles of hydrogen, 1 mole of oxygen. While I can round the 3.039 to 3, that's fine, I cannot round 3.5 to 4 because I have to be within a tenth of my whole value. So instead what I have to do is take all of those numbers of moles and I now have to multiply by 2. So the empirical formula that I get is C7H6O2. So this problem is extremely similar to the empirical formula problem that we did previously. It's just added on the component of having to figure out the mass of each of your elements before you've started.